Hello students, in this module we are going to talk about the extraction of iron. So as usual we need to talk about the uses of iron. The very first uses, it is used for making railway sleepers as well as giant stoves in the industries. Secondly, it is used for the pipes and also for a lot of construction purposes. Third, it is used for making an alloys like steel. So these are some of the uses of iron. Now talking about the commercially available iron. Commercially there are three types of irons which are possible. The first one is the cast or the pig iron. The second commercially available iron is the wrought iron, and the third one is the steel. Now what is the difference between these three types of iron is only the carbon content. The very first one contains 4% carbon, whereas the wrought iron contains less than 0.2% carbon, and steel contains iron between 0.2 to 2%. So talking about the first one, where it contains 4% iron, cast iron or pig iron, they are hard as well as brittle. Wrought iron is the soft form of iron, and steel comes in between. That is, they are neither soft nor brittle. All you have to remember is the wrought iron, we call it as the purest form of iron, whereas the cast or the pig iron is the impure form of iron. Well, these are some general things about iron. Now let us talk about their extraction technique. So the very first thing is we need to start with the minerals and ores. Iron in nature can exist in several forms. It can exist in the nature in the form of hematite, it can be in the form of magnetite, or it can be in the form of limonite. It can also be in the form of iron pyrite. Finally, it can also exist in the carbonate form, which is the siderite. All this we call it as a mineral, but the ore of iron is hematite, which is Fe2O3. Talking about the second one, we will talk about the concentration technique. In the concentration technique, first of all, we will do hydraulic washing, where all the lighter gangue particles will be washed with water. And the second thing that we need to talk is the extraction. As we know, extraction involves two steps. The first step is converting a metal compound into a metal oxide. Now you might wonder, iron oxide, that is Fe2O3, that is hematite, is already in the form of an oxide. So why do we need to do the first step? Please remember, Fe2O3 also contains a lot of FeO. That is, ferric oxide also contains a lot of ferrous oxide. So what should we do is we should roast it. So when you roast it in the reverberatory furnace, FeO, also heated in the presence of oxygen, may get converted into Fe2O3. So this way, the entire ferrous will also get converted into ferric oxide. Well, that is the first step. Secondly, if at all there are certain impurities like sulfur and arsenic, they will be removed as volatile gases. Well, that is the first step. Talking about the second step of extraction, which is reduction. So reduction of oxide, metal oxide, into free metal, which can be done by three methods: hydro, pyro, or electrometallurgy. And the method that we'll choose for iron is pyrometallurgy. And whenever we do pyrometallurgy with the help of a carbon as a reducing agent, we will call that process as smelting. And this smelting of iron is basically done in a blast furnace, which looks like this. So now it is time for us to talk about the working of the blast furnace. So let us take a nice look at this blast furnace. The very first thing is we are trying to obtain iron from hematite, which is Fe2O3, and since we are doing smelting, we need to take carbon, and we will take carbon here in the form of a coke as a reducing agent. But this Fe2O3 contains silica as a major impurity. Now silica is an acidic impurity, hence we require a basic flux, and the basic flux that we are adding over here is limestone. So we will take Fe2O3 and carbon and limestone in the ratio of 12 raised to 5 raised to 3, and these all raw materials will be introduced into the blast furnace from the top of the arrangement called as cup and cone arrangement. So once you put it, what will happen is the carbon will heated in the presence of an oxygen. Now the question is, where do we get that oxygen? So a blast of preheated air is blown through the tuyeres. So because of that, carbon can react with oxygen, and they may lead to the formation of carbon monoxide. As you know, anything burned in the presence of oxygen is called as combustion reaction. So here the temperature as this zone becomes nearly 2000 degrees Celsius, which is very, very hot. Now this carbon monoxide which has been formed can behave like an excellent reducing agent, hence they will react with the incoming hematite ore, and they will reduce them to give us corresponding iron, and carbon dioxide gas is given out. And we know carbon monoxide is an excellent reducing agent, and by the way, even carbon is a good reducing agent. So they will react with the incoming ore, and they may lead to the formation of Fe, and this time we will get carbon monoxide. And this zone where this reduction is taking place, the temperature is approximately 1500 degrees Celsius. Well, now it is time for us to talk about the impurity. Yes, in order to remove the acidic impurity, we have added a basic flux. So at a temperature of around 1200 degrees Celsius, limestone will decompose to give us calcium oxide and carbon dioxide. Well, this calcium oxide will react now with the acidic impurity, and they will lead to the formation of a slag, and this zone where slag is being formed, the temperature is nearly 1600 degrees Celsius. So if you see the beauty of the blast furnace, from the bottom to the top, the temperature keeps on decreasing, and at each zone different reaction takes place. For example, that zone where combustion reaction was taking place, that is called as zone of combustion, and at that zone where reduction was taking place, that was called as zone of reduction, and that zone where slag is being formed, that is called as zone of slag formation. So the iron which is formed at the top, after melting, will flow down and they are obtained from the lower outlet, and the slag, which is calcium silicate, can be removed from the upper outlet. So this is the extraction of iron through blast furnace. So now let's have a quick revision on the entire flow chart. So we have started with hematite, and this hematite, after undergoing hydraulic washing, gave us concentrated hematite, which has to be roasted to get us roasted Fe2O3, which has to further undergo pyrometallurgy, precisely smelting, and ended up in pig iron. So now the question that can be asked over here is this: in the modern blast furnace, the charge consists of a mixture of, the right option over here would be C, because it consists calcined iron oxide, limestone, and also coke as a reducing agent. The second question over here is, in the blast furnace, the highest temperature is in, the right answer is the zone of combustion, where the temperature was nearly 2000 degrees Celsius. And the third question here is, the inner layer of the blast furnace is made up of fire clay bricks, that is option C, which can withstand a very, very high temperature. The fourth question over here is, which of the following is having the highest melting point? We should always know a pure substance will always have a highest melting point. So the purest form of iron over here is the wrought iron, and wherever impurity is present, the melting point will decrease. And going to the next one, cast iron is obtained from, though I said cast iron and pig iron are same, no, there is a difference in the carbon content. So the cast iron is also obtained from pig iron. Thank you.